Here we have a SAT math problem. Okay, let's cover the question. Point Q is the center of the circle. Point A, point B, and point C all lie on the circle. Point D lies on segment AC as shown. Segment BD is perpendicular to segment AC. In the figure shown, AB equals to 58 and AD equals to 40. If a point within the figure is selected at random, what is the probability that the point is within the shaded region? Express your answer as a decimal or fraction, not as a percent. Round your answer to the nearest and thousandth. Okay, here we select a point at random within the given figure. Actually, the given figure is a circle. Since a point is selected at random within the circle, the area of the circle should be considered as a sample space. The area of the circle should be written in a denominator. And in numerator, we have to write the stuff for which we have to find the probability. Actually, they are asking us to find the probability that the point is going to be within the shaded region. Then we have to write the area of the shaded region in numerator. So to get the required probability, we have to write the area of the given figure, that is area of the circle in denominator and area of the shaded region in numerator. Okay, we can get the area of the circle using the formula pi r square. So we need the radius of the circle. Once we get the radius of the circle, we can get the area of the circle. Okay, how do you have to get the area of the shaded region over here? For that, we have to find the area of the triangle we have over here. We have to subtract the area of the triangle from the area of the circle to get the area of the shaded region. Okay, now let's mark the given information. We have AB equals to 58. Here we have the line segment AB, its length is 58 and the length of AD is 40. Let me mark it over here. And also the line segment BD is perpendicular to AC. Here we have BD, it's perpendicular to AC. So we have right angle over here. Now, let me consider the line segment AC over here. Actually, it is a chord and this chord is passing through the center of the circle. In a circle, if there is a chord passing through the center, then the chord is the diameter. So this line segment AC over here represents the diameter of the circle. Then this is semicircle and this semicircle subtends an angle at point B on the circle over here. Okay, whenever a semicircle subtends an angle at any point on the circle, then it has to be a right angle. So here we have right angle at the point B on the circle. Clearly, this ABC is a right triangle. Then this side AC represents the hypotenuse of the triangle because it is opposite to the right angle. In a right triangle, apart from the hypotenuse, when I consider the remaining two legs, one of the legs should be taken as the base of the triangle and the other leg should be considered as the height of the triangle. Then we can use a formula base times height divided by 2 to get area of the triangle. Okay, now in this right triangle ABC, since AC is hypotenuse, we have to consider the remaining two legs AB and BC as the base and the height of the triangle. Then we can use a formula to get area of this triangle. Already we have the length for the leg AB over here. Still we have to get the length of the leg BC over here. Then we can get the area of this triangle. And also we have to get the length of the diameter AC. Once we get the length of the diameter AC, we can divide it by 2 to get the radius. Once we get the radius, we can find the area of the circle. Okay, now our aim is to get the length of the leg BC of the triangle and also the length of the diameter AC. How do we have to do? Okay, for that we can use a similar triangles concept over here. Now let me consider two right triangles. One is the smaller right triangle ABD over here and the other one is a bigger right triangle ABC over here. Okay, A is a common vertex for both the triangles. Now let me consider two interior angles in the smaller right triangle, that is A and D, and two interior angles in the bigger right triangle A and B. The two interior angles of the smaller right triangle are equal to the two interior angles of the bigger right triangle. Then by angle similarity postulate, these two right triangles are similar. Okay, then we can equate the ratios of the corresponding sides and we will get a chance to get the length of the diameter AC or the side of the triangle and the length of the leg BC of the triangle. Okay, let me write the similarity statement. Let me take a vertex from the smaller right triangle ABD over here. That is a vertex A and it is a common vertex for both the triangles. Okay, so vertex A in the smaller right triangle and vertex A in the bigger right triangle. Let me consider the vertex D at where we have right angle in the smaller triangle and the corresponding vertex in the bigger right triangle is a B, because at where we have the right angle. Let me write over here. The third vertex in the smaller right triangle is a B, and the third vertex in the bigger right triangle is C. Okay, by angle similarity postulate, these two triangles are similar. Okay, now let me take the side AD in the first triangle, that is smaller right triangle. The corresponding side in the bigger right triangle is AB. Okay, here I got the ratio of one pair of corresponding sides. Let me consider the second side DB of the smaller right triangle. The corresponding side is BC in the bigger right triangle. Let me take the side AB in the smaller right triangle. The corresponding side is AC in the bigger right triangle. Since these two triangles are similar, the ratios of the corresponding sides must be equal. That is, the corresponding sides are proportional. Now let's plug in the known lengths over here. For AD, we have the length of 40. Okay, let me plug in 40. And for AB, we have the length of 58. And for DB, I don't have the length, but we can get the length of this line segment DB over here, because it's one of the sides of the smaller right triangle ABD over here. And we know the lengths of the other two sides. We can use Pythagorean theorem to get the length of this line segment DB. Okay, now let me write a Pythagorean theorem in the smaller right triangle. That is DB square positive AD square equals to AB square. Okay, in this smaller right triangle, AB is hypotenuse because it is opposite to the right angle. When I take a sum of the squares of two legs, it must be equal to the square of the hypotenuse, that is AB square. Okay, I do not know the length of DB. Let me keep this DB square as it is. And for AD, I have the length, that is 40. Let me plug in 40 for AD over here, that is 40 square. And for AB, we have 58, that is 58 square. Then we get DB square. When I evaluate the value of this 40 square, I am getting 1600. Okay, now let me evaluate the value of this 58 square. It is 3364. Okay, let me subtract 1600 from both sides. When I do so, this positive and negative value will cancel out. I am getting dB square equals to, okay, let me evaluate the value of 3364 negative 1600. When I do so, I am getting 1764 on the right side. Let me write it over here. Now to get rid of the exponent 2 over here, I am taking square root on both sides of this equation. On the left side, this square root and square will cancel out. Usually when we take square root on both sides of an equation, one of the square roots will cancel out, and for the other square root, we have to consider positive or negative sign. Here on the left side, we have dB, which represents the length of one of the sides of the triangle. It cannot be negative. So here we don't have to consider positive or negative sign. We can consider this value as positive. Okay, here we have dB on the left side. On the right side, okay, now let me get the value of square root of 1764. That is 42. Okay, here I got the length of the side dB of the triangle, smaller right triangle, that is 42. Okay, now let me plug in this 42 for dB over here, 42 divided by, and for BC, I do not know the length, so I have to write this BC as it is. And for AB, I have the length, that is 58. Let me plug in. And for AC, I do not know the length. I have to write AC as it is. Okay, now three ratios are equal. Since all the three ratios are equal, we can equate any two out of these three ratios. And when I consider the first ratio, both the quantities are known, 40 and 58. When I equate the first ratio and the second ratio, I can solve for the length of the side BC of the triangle. Okay, now let me equate the first and second ratios. Then I'm getting 40 over 58 equals to 42 over BC. Now let's do cross multiplication. Then I'm getting 40 times BC equals to 42 times 58. Okay, let me divide both sides of this equation by 40 to solve for the length of BC. Here 40 will cancel out. Okay, now let me evaluate the value of 42 times 58, which is 2436. It has to be divided by 40. Then I'm getting 60.9. That is the length of BC is 60.9. Okay, now let me equate the first ratio and third ratio to get the length of AC. Okay, now let me do it. That is 40 over 58 equals to 58 over AC. Let's do cross multiplication. Then I'm getting 40 times AC equals to 58 times 58. Now I divide both sides of the equation by 40. Okay, here this 40 will cancel out. I am getting AC on the left side. Okay, now let me evaluate the value on the right side. That is 58 times 58. that is 3364. It has to be divided by 40. Then I'm getting 84.1. Okay, let me write over here. Okay, here I got the length of the diameter, that is 84.1, and also I have the length of the leg BC of the right triangle ABC, that is 60.9. Now, to get the radius of the circle, what we have to do is we have to divide the length of the diameter AC by 2, that is 84.1 divided by 2. Then R equals to, okay, let me do it, 84.1 by 2. I am getting 42.05. Let me write it. Okay, here I got the radius of the circle. Okay, here we have all the information to get the area of the circle and also to get the area of the bigger right triangle ABC over here. Now, let me erase this stuff and continue the problem. Let's get the area of the circle. Okay, let me write the stuff over here. That is the area of circle. The formula is pi r square. Already we got the radius, that is 42.05. Let me plug in this value for r over here. Then I'm getting pi times 42.05 the whole square. When I evaluate the value of this one, 42.05 the whole square, I'm getting 1768.2025, and we can write this pi over here. Now, let me get the area of the bigger right triangle, that is the area of a triangle ABC equals to the formula's base times height divided by 2. Already we know that this AC is the hypotenuse of this bigger right triangle because it is opposite to the right angle. Okay, when you consider the remaining two legs AB and BC, we have to consider one of the legs as the base and the other leg as a height. Okay, when you consider this leg AB as a base, then we have the length 58 for the base. Let me plug in this 58 for the base B over here. And when I consider this leg BC as a height, we have 60.9 as height. We can plug in the 60.9 for height H over here. Then I'm getting times 60.9 divided by 2. Okay, using calculator, when I evaluate the value of this one, I am getting a 1766.1. Okay, here I got the area of the circle and the area of the triangle ABC over here. Now let me get the area of the shaded region. Let me write the stuff over here. Area of the shaded region. Okay, let me finish writing. Okay, to get the area of the shaded region, we have to subtract the area of this triangle ABC from the area of the circle. Then I'm getting 1768.2025 pi. That is area of circle, negative area of the triangle 1766.1. Okay, here I got the area of the shaded region. Now let's go to the question. If a point within the figure is selected at random, what is the probability that the point is within the shaded region? Since a point is selected within the figure, that is the circle, we have to consider the area of the circle as sample space to get the required probability, and the area of the circle, that is the sample space, should be written in denominator. Okay, now let me write the stuff over here. Okay, to get the required probability, we have to write the sample space in denominator, that is the area of the given figure or area of the circle. We got it already, that is 1768.2025 pi. In numerator, we have to write the stuff for which we need the probability. We have to find the probability that the point is within the shaded region. So we have to write the area of the shaded region in numerator. Already we got that. Let me write this stuff for here in numerator. That is 1768.2025 pi negative 1766.1. Okay, we can use Desmos graphing calculator to evaluate the value of this expression. Let's go to Desmos. Here we have Desmos graphing calculator. Okay, now let's evaluate the value of this expression. Let me give this expression as input over here. That is 1768.2025 pi negative 1766.1 divided by 1768.2025 pi. Okay, here I got the value of the expression, that is 0.682068. It keeps going. According to the instruction value, this value has to be rounded to the nearest thousand. When I round this value to the nearest thousand, I am getting 0.682. Therefore, the required probability is about 0.682.